Hi everyone, welcome to today's webinar, Test and Evaluation in Core. My name is Katie and I'm the Communications Manager here at Vitech, and I will be your host during today's webinar presented by Ron Kratzky. We are excited to talk to you about testing your system design. Our lead presenter today is Ron. He's our Principal Systems Engineer here at Vitech. He is a retired United States Navy officer with over 20 years of engineering experience, managing nuclear engineering and combat systems on surface ships. Ron was introduced to the systems engineering practice near the end of his naval career while conducting mission and capability analysis for the Navy staff. For the last 12 years, he has worked as a systems engineer supporting advanced systems development for a number of federal government agencies. He was introduced to CORE in 2007 and utilized CORE to manage system development tasks on 3 different projects in the 5 years before he joined the Vitech team. He is now a provider of professional services in CORE as well as a central part of the Vitech training team. Before Ron gets started, I do have just a few housekeeping items. We will be answering questions today at the end of the webinar. Please send your questions in as soon as you think of them through the question tab on your webinar control panel. Ron will answer as many questions as he can today, but if we don't get to your question, we will reach out to you after the webinar. We are recording today, so if you experience any connection problems during the live presentation, a recording will be available within 1 business day of today's live version. The recording will be published to Vitech's webinar archive located on our website. I will send the link out via the chat window now, and there's that for everybody. And now I'm going to turn the presentation over to Ron. Welcome.
Well, good morning or good afternoon, Katie. I guess it's just afternoon now. I am excited to bring this information to the crowd out there. Testing and evaluation in CORE and using the facilities that we have in CORE is an often overlooked or not realized capability that's in CORE. And what I'm going to talk about today is how to manage your test and evaluation process as a systems engineer using the MBSE principles that we use and how those principles are instantiated in the CORE schema. So if I can get my machine to change its slide here. There we go. So first, when I say model-based systems engineering, what I mean is using some sort of formal tool, formalized application of a model to support systems engineering. And we often talk about the MBSE and when it comes to models or when it comes to requirements and functional analysis and physical architecture, but the one thing we miss many times is that MBSE, model-based systems engineering, is also meant to be applied to verification and validation activities, and that we ought to be able to handle those activities from conceptual design all the way through later life cycle phases. Well, what does it mean when we say we have to do verification and validation activities? To put that in context, if we look at what INCOSE talks about as far as the verification process, they are great about giving us these charts, and they talk about what inputs, outputs, controls, and enablers we have. But what we're going to focus on here is using all these requirements, how do we plan verification and perform verification activities? And that's the fundamental crux of what you need to do as a systems engineer, is to make sure you've planned those activities. I'm not going to talk today about how to actually write a test plan or how to do the details of test and evaluation, but I'm going to talk primarily about how to manage the planning and the performance of these verification and validation or the verification activities. Now, it's important to understand that what the difference is between verification and validation. When I talk about verification here in this context, and sometimes verification takes on a different meaning in some communities, but I'm talking about how to verify that the system meets the requirement as stated. Validation, on the other hand, is looking at a requirement and making sure that that requirement is a valid requirement. Does it state what the customer wanted? What I'm looking at here is, verification. In other words, how are we going to verify that the requirement as written is satisfied by the system? And so what we're really looking at is, and the way we do verification is in our test and evaluation program. So if we're going to do a verification validation model, we have to provide insight into the test and evaluation concept for the system. As we do this, because we're going to have a number of requirements, we have to provide order and traceability into the verification activities that we plan. Additionally, we have to make sure that our test and evaluation activities are consistent, and that there's a consistency between the test and evaluation and the system design. And there's a little typo there. I have "and" instead of "and." Katie will ask me a question about that because she's our QA manager in addition to everything else at the end of the day. So one thing I have to fix, Katie, in the final production of this. And the last thing we need to be able to do is demonstrate and explain our test program to people that are not organizations that are not part of the detail engineering design team. Now, commonly we talk about verification through a requirements verification traceability matrix. Okay, typically, a requirement verification traceability matrix shows us the requirements that we have in the system and dictates a method of verification. Those methods include things like analysis, demonstration, inspection, and test. I think every place I've ever been, anywhere I've ever worked on a systems design model or systems design, we always had analysis, demonstration, inspection, and test. You may have some other specific ones in your organization, some other additional types of or additional methods, but just about everybody uses analysis, demonstration, inspection, and test. And I won't get into what each of those means, but let's just know that we're going to have a method that we want to use to verify our requirements. And typically, this requirements verification traceability matrix looks something like this, where on the left-hand side we have a requirement number, whether it's a project unique ID number or a number that we use in core, and we'll have some sort of name for the requirement and some sort of shall statement. And you'll see something called method, and it'll list that analysis, demonstration, test. And in this example, we have a number of requirements, and over on the far side we have a method for those requirements. But while this is normally in a performance spec, it really doesn't tell us much about the details behind how we're going to do test and evaluation. It says we have a method, and assuming we have a description of what analysis means to us on our project, and we know what testing means on our project, it really doesn't give us much insight into the specific details of how we're actually going to do our testing and evaluation. And so what we really want to know is more. In addition to the method, we need to know other things about how the requirement is going to be verified. We need to know what is the objective of the verification. If I have a requirement to do something in test, what is going to be my my criteria for success? What's the objective of this verification? What environment are we supposed to use to do the verification test? How is the verification test going to be performed? Do we have any special conditions that we have to verify? And finally, what is the success criteria? You can read more about these statements and why they're in there in a paper produced by Steve Skukanik from Northrop Grumman. And if you go out and Google this paper, A Day in the Life of a Verification Requirement, it's a tutorial that Steve gives at T&E conferences, and he'll also be giving the same tutorial at the NDIA Systems Engineering Conference here in DC later on this month. But he talks about why you need to have those things in there, but it sort of makes sense if you just think about it. I recently worked with a customer where they were working on a hydraulic system, and the hydraulic system was specified to operate between two pressure set points, let's say 800 and 1200 pounds. And their accumulator was set so that when it got to 800 pounds, the system charged back up 1200 pounds, and then that's the way the system operated. Well, the reason the pressure was set at that level was because they needed to have enough force to close a particular set of valves within a certain time set point. And when they did their test in the lab, everything worked fine. When they put the equipment out in the field and they ran it through several different operational scenarios and stuff, they couldn't get the valves to close at a specific time. What happened was, in test, they tested the system at 1,000 pounds because 800 to 1,200, the 1,000 pounds seemed to be on a great nominal set, a great medium, and so they tested it several times at 1,000 pounds. What they didn't do during the test is they didn't test it at 800, they didn't test it at 1,200. And they also found out that when they closed 2 or 3 valves in close sequence, they didn't have enough pressure in the accumulator to close the valves within the time frame. So if they had written their verification requirement to say, we're going to test the ability to close the valves within the system pressure, and we're going to test it at 800, at 1,000, and at 1,200 pounds, and if they had said something like, we're going to test them at these 3 set points, maybe 2 or 3 times at those set points, and the success criteria was 8 out of 10 times that they had to close within a certain time frame, they would have got much more information in test and would have avoided those problems in the operational side of when they went out to operational testing. So what does a verification requirement look like then? So a verification requirement has to be related to the requirements and functions in our system, and in core we use the verified by relationship. So any requirement or function gets verified by a verification requirement. Now this verification requirement in core has a couple of key attributes. We have a description, and I'll talk about what we put in that description. Basically, in the description block, we're going to put all that information about the objective and the environment and the special conditions and the success criteria. We have a status, we have a method, and we have a level. That method, that attribute called method, is where we look at demonstration, analysis, inspection, and test. Status is a way for us to track whether we've planned this verification. Is it in progress? Is it completed? Satisfactory? Is it completed unsatisfactory? And the level gives us an idea of where this verification requirement aligns itself to the overall system architecture. In other words, we could be doing verification requests on a subsystem only, or we could be doing them on a system, or we could be doing them on an individual component. And so there's a way to track that by the level. So that verification requirement in core looks like this. Okay? In this case, we have this requirement called provide products. We've given it a number, VR. We commonly use VR as the number in core, as opposed to R, which is the requirement, what we commonly use as abbreviation for a requirement. And you'll see there in that description where, in this description, I've addressed those questions about the objective and the environment. So I've said verify by test, but the system provides a particular output. I want to use data, including images, file metadata, file name generated. So I've got a description of the data I have to use. The test will show the image file. Retrieval will be requested by some terminal. The testing will be done for a minimum of 3 images for both electronic and paper output. And the test is successful when each image is requested and produced in the desired format, is legible, and all metadata is properly displayed. So that's what I mean by the verification requirement is more than just verify by test. We go through and we actually describe what it is we want to see as systems engineers in that test. We're not writing the actual test procedure. That's the purview of the test and evaluation engineers. the test and evaluation engineers as subject matter experts should be helping us as systems engineers to write these verification requirements and make sure that they're aligned with the actual requirements. So we understand that we have some verification requirements, and we put a little more, if you will, information, more meat on the bones here besides knowing the method. But our job as systems engineers doesn't end there. Just because we have requirements and we've got some verification requirements, there's other things that we need to be looking at as systems engineers. So we need to look at, we also are responsible as systems engineers to understand how we're going to test, the overall process of testing the system, the subsystems, whatever. And so we need to know things like, how will the verification requirement actually be verified? In other words, how will it be done? What type of event? Where, and it could be through several events. When is it going to take place? We may need to have certain tests done earlier on in the system. We may need to have some things done before we go to CDR because we want to make sure that what our solution is achievable, is feasible. So we may have some tests that are done before CDR, for example. Who is going to do the verification test? It's not always the system design team. It could be sent out to a separate test facility. It could be sent out to, or it could be that you're going to do a test, and then the government is going to do a test to double check what you're doing. So you got to plan for those sorts of things. What's the status of the planning? Once we have the verification requirement written, what's our plan? What's our plan to actually accomplish that? And how far along are we? The systems engineers are responsible to make sure all of that gets done in most programs. But you need to understand how that's happening, especially as a systems engineering manager. Will the verification test verify one or more than one requirement or function? So you could write a verification test, the verification test statement that's going to actually verify more than one requirement or function. And likewise, you also need to show from the requirements and functions that every requirement and function has at least one verification requirement associated with it. And then once it's actually planned and you actually assign it to a test, what's the status of completing the verification? So now we start complicating our simple little model. We started out with just using function and requirement and just the attribute from the verification requirement of analysis, demonstration, inspection, and test. Now we've got some more things that we want to manage in our MBSE model. So first of all, we want to look at a verification requirement, and we want to see where's that verification requirement going to be tested under what event. And when I say verification event here, I mean things like laboratory integration test, a limited users test event, maybe a subsystem demonstration event, etc., etc. So these are the types of events. So an event, a verification event, is going to fulfill a number of verification requirements, which in turn will trace back to a number of functions and requirements. But the model shouldn't stop there. Don't we want to know who's going to do it? And so we can track the verification event to an organization that's assigned to actually do the to do this verification testing for us. And then we can look at what test procedure is going to be employed and what test configuration is going to be employed to actually do this test. Now, don't misunderstand me here. In core, we talk about a verification event employs a test procedure. That test procedure is just an element in the architecture. It is not the actual test procedure document. That document is something that the test and evaluation SMEs would write up, or even your design SME, your component design subject matter experts would write up. And that's the typical test procedure, like turn the system on, make sure the green light powers up, the bit check is done, and you have an initial or maybe a seconds, and then perform these steps, make sure that this data information is achieved. That's the actual test, the test document. That test document would reside outside of core. I wouldn't write the test document inside core, but I would say that the verification event has this test procedure and it's going to do these types of things, and it's going to be augmented by or related to this external file, which is the actual test procedure. And then employing a test configuration, many times we have a particular test bench or test equipment that we need. So we track getting and having all those test configurations. So let's look at what this verification event is in core. So the verification event in core is another element in the database, and again, the verification event is related to verification requirements in that it fulfills a series of verification requirements. And again, we have a name and number and we have a description, but here's the next important part about this is that on verification events at the bottom of the main attribute page, we have a duration and a start and stop date for verification events. This allows us as systems engineers to understand when these events are occurring in the project plan. So overall in a project we might be finishing the manufacturing and we want to look at how are we going to move things around to different verification events. Now we have some idea when these verification events occur, and I can actually align equipment with those verification events in core. And because I have this schema here in core, now I can start looking at how do I trace some verification requirements to make sure I have all the things I need to do the test. So now I can do a verification requirement traceability, and I can see these things. So I can have a verification requirement being fulfilled by a verification event, and I have a complete picture here. For any verification requirement, I now know who's going to do it, what it's going to employ, as far as a test configuration and a series of test procedures. This is a verification requirement traceability hierarchy diagram in core. We'll look at how this comes out in a couple of minutes here. And we can also do this by a table. This is merely a table extract in core, and I'll go into core here in a moment and demonstrate some of these tables. So here's the verification requirement traceability by table. So I can trace from a requirement to a verification requirement to a test event. Now this verification requirement traceability is adding some additional information. It's showing me not only the requirement that I have, but it's showing me what verification requirements are going to be used to verify that requirement and what test events I'm going to do that on. So in this case we have the first one, we have control multiple collectors. We have 3 different verification requirements, and we labeled those to show laboratory, ground, and flight testing. And we have some verification events that are out there that are associated with those verification requirements. We can also look at, because of the nature of the schema that we have, we can also look at the management of the verification event. So when we get ready to do a verification event, we can ask for any particular verification event, who is the test organization, what test configuration and test procedures are they using. So we can manage and track and make sure that our test procedures are done and ready to go. They've been accepted. Generally, there's an approval there. Do we have all of the test support equipment, the test configuration equipment, ready to go for those particular events? And finally, combining all the last 3 tables, we now get to a much larger RVTM. At the beginning of this presentation, I talked about a requirement verification traceability matrix where we had the requirement number and the name, and all we said was the method of the verification. Now we have much more. We have a lot of expanded information here. We have a number and a name. We have a verification requirement, a verification name. We have the method, but we also know whether this is planned or in progress. Here you have a test that's been completed satisfactory, and we understand the level of the system test. much more information expanded out so that the engineer understands what's happening to the system through the verification process. So I'm going to pause here for a moment and go into core and show you where these elements are. So if I go into core and I have a core database open here, I have a series of verification requirements here, and these verification requirements, I'm in the all classes facility here, so I have the verification requirements here. And if I select one, you'll see some text here for what the verification requirement is. I have a status, a method, and a level in here, and you can see some of the relationships here. It's executed by a test activity, and I'll cover test activities in a moment and how we can use test activities to help us manage the resources for testing. But it's fulfilled by this verification event. It's reported in my test and evaluation plan, and it verifies this particular requirement. And if I was to look at a hierarchy here, if I take and look at the hierarchy diagram for this, you can see that this particular hierarchy, and it's a verification tree hierarchy, okay? It's showing me this verification requirement is fulfilled by, what I'll do is I will auto-size these icons so we can see everything. So the verification requirement here is fulfilled by this this verification event, okay, and then it's assigned to this organization. It's employing this test configuration, and this test configuration, and this test procedure. Okay, so there's the hierarchy traceability. I wanted to show you also that this verification event, media usage testing, if I go to this verification event, you can see for this verification event, I don't have a duration and a start and stop date on this particular one, but I have all that information related to it as to what it's using. Okay. Now, the other thing I showed was a verification requirement traceability. I wanted to walk from requirements to the verification requirement to the test event. So if I have a couple of tables that I've created here in my model where I can I'm going to start in requirements here because I want to show requirements to verification requirement to test event. So I'm going to start in requirements, and I'll go to, I'm going to go requirement to verification event. And what I've done here is I've created a table where I start in requirements, and I'm going to pull out the requirements. I'm going to show the verification requirement, and then I'm going to show the test event and who it's assigned to. Actually, I don't have that column being shown right now, but I can also include that column. So I'm just going to go next and bring this out. We'll create this output, and you'll see here I have a series of requirements here, not all of which are planned at this point, but I can see the verification requirement and the test event that I'm using to complete those verification requirements. So I could use this report as a systems engineer to understand that I don't have verification requirements written for these elements. I probably need to, especially on the lower level leaf requirements. So I need to go back and get the verification requirements and align them to the verification, the test events that I have planned, or plan new test events in order to cover these. Okay. The second table I showed on slide 15 was how do we manage the verification event. So what I did for that is I created a table in core, and if I start in the verification event, or the verification event this time, and I'm going to run what I call the verification event table. And you can see here I'm starting with the verification. I'm pulling the element name out. It's assigned to a test organization and it employs a number of items, but I'm going to pull out the class and the element name for that class into this table. And so there you go. So I've got the verification event, the test organization, the test procedure, and whether it's a test procedure or a test configuration. And finally, we have the table that I looked at a moment ago was the expanded RVTM. So again, we're going to start in requirements here, and we will pull up a table requirement to verification information. And what I did here is I traced from the requirement, starting in the requirement class, verifies the number, pull up the element name, the method, the status, and the level. And you'll see that in this table. Now, I must have made a mistake when I saved it last time because I didn't complete it, or I started in the wrong place. But that table is this table right here. Now, related to verification event planning is this notion of test activities in core. A test activity in core is used to model the actual testing. Test activities verification requirements are executed through discrete test activities. Test activities can also be related to verification events by extending the schema and using this accomplished by relationship if that's where you think you need to go in your modeling. But the test activity gives us the ability to model the actual testing process. Okay, what that process is. This is the test activity and the process. So what a test activity does is it gives us, first of all, these unique sets of attributes. So I can describe the test activity. I get a type and a title. I can tell you that it's a start, stop, and a duration. So if you look at this sort of looks like some of the information we have in functional analysis. And then there's some additional information in here about completion criteria, prerequisite, and special comments. And then the other thing about a test activity class is they can have an input, an output, and a trigger. They can utilize resources, and they can be modeled and simulated. So what happens is we can look at test activities this way. So I can look at this particular test activity called request media test activity, and I can see to do this test activity, to do this test, I have a duration for how long the test is going to take. I have resources I have to use down here to actually perform the test. I can look at the resources that I need to do the test. In other words, in order to develop the test procedure, obviously I have to utilize a test engineer. When I actually do the testing, I have to utilize a test engineer. And when I'm producing the media, and when I produce the test report, I have to use a test engineer to actually produce the final test report. And so I've added here in this particular drawing, I added the resources that I needed and some products and the test duration, the overall test duration. And you can see here, because I've done this in the EFFBD model, you can see that the service performance test precedes this test, And when I finish this test, then I can go into some sort of ground testing program, which may have a whole other series of events and things that need to occur. So in core, what happens is this. I can look at test activities here, and I think I was looking at this request media test activity on the PowerPoint slide, and you'll see here's this actual process, this model, and these are executable just like an EFFBD. I can take this, I can reset, run it. It doesn't really give us much information right there. Why? Because I don't really have the resources in here. If I take core and add my resources in here, I'll just check all. Now I can see, and this is a pretty small test procedure, but I know that I have 3 of my test engineers. I'm only using 1 on this particular project. But you can see the usage and utilization. The resources really come into play if I look in my model at a higher level. If I go up here to the overall test program, you'll see a test program here where I have all of these things going on. Okay, and if I look at this and simulate this, for example, you can see. Again, I have to add my resources, show my resources in here. And you can see through this overall test sequence, how many engineers am I using, how many fax lines am I using, how my resources are being managed through my overall test program. And you can see here that I can actually run these 3 in parallel. I only have one time here where I'm waiting for probably an engineer to actually provide me enough resources to do something. And when I run this, many times I'll put 1, 2, 1, 3, and 1, 4 in sequence. And if you ran this model in sequence, the sequence would take over 190 days. When I put them in parallel, you can see that I can do these in parallel, and it will reduce my test plan by over 60 days. So it's just one of the things you can do in core to help you manage your testing resources. Let me close this. And then finally, back in our presentation here, so we can do this detailed test planning as a systems engineer. And then finally, the last thing I can do is I can produce a test and evaluation plan from the core model. And when you do that, the way we do it right now in core is we look at a series of verification requirements and see how we're doing. What's our test and evaluation plan for the series of verification requirements that we select to do the in the model. So if I go back to core a second here, you can see here in core, I'll show you the testing evaluation document that I have here, and I'm going to report on these 3 requirements in my TEP. And when I set that all up and would run my subsections, you can see I can do this. I'll run the testing evaluation plan. I know I have no table in there, so I'm going to remove that and just say OK. And I'll get a TEP here. And it's a typical RTF output from core. I can do this. When I walk down through it, you'll see the this is all the front matter here, what I'm running that's talking about geospatial library requirements, etc., etc. Here's the applicable documents that are wired into the document. And now I'm looking at, here's the test I'm actually doing, verify by test. Here's the status and the information associated with it, the type of verification, the schedule of events, what's being used. Here's the next requirement, and all the way down through the requirement list. And finally, we get to the acronyms, abbreviations used in the TEP. So the TEP gives you a complete picture of, for those requirements that you specify here, of how you're actually testing them. We just close the document out for everybody, and then we go back into presentation here. So when you look through all that, we have a model-based systems engineering verification model actually built into core. And it can extend and provide you a lot more information, enhanced information than over what the traditional requirement verification traceability matrix provides. We can look at verification events and the support resources that are there. We can model how we're going to actually do the verification requirements in using the test activity, and we can provide test and evaluation plans. Overall, as the engineer, what you need to know, the fundamentals are, you have requirements or functions, you need to create verification requirements for those functions, and you need to trace them to verification events where they'll actually be, so those requirements and functions can be verified. The model that we have in core allows you to do the traceability of, that's listed there, requirements of verification event. You can show completeness in that all your requirements have verification events and they're going to be covered, or all requirements have verification requirements and they will be covered in verification events. And you can show that you have consistency in your model in that everything is covered and tracked throughout there. So I see that Katie probably has some questions here for me. So Katie, what do you want to know? What else does what else do they want to know?
All right, we've just got a few questions, but you still have a chance, if you have any additional questions, to go ahead and submit those through the question pane on your control panel. And let's see, so we have a question from James, and he would like to know if core interfaces with tools such as HP Quality Center for test management.
There is not an off-the-shelf interface for any of those tools. You can interface with any tool via core by using a CSV import or export. So I can export any of the information I have in core through a CSV, and then you can import it into those tools for the detailed test planning events that you need to do in those tools.
Okay, thank you. And so you have a question from Vincent. Where would you identify conflicts in utilizing lab assets or resources using test activity to model your test planning?
So if I had a conflict here in a test activity, I would actually what I do is if you go up to concern, I would take a concern, and any of these concerns, I could make a new concern, and that concern is generated by, and you can pick what's generating that concern. So it would be a verification requirement that you have, and you could trace that even from there down into what the issue is with the verification requirement. Okay?
All right. And Vincent did have one more question. Is there a way to generate an HSCM as you move into T&E activities?
HSCM. I don't know what that acronym means.
Okay. So Vincent, if you're still there, if you could let us know what you're referring to with that acronym, I'll go ahead and move on to the next question. We can come back to that one. Oh, he just responded, hardware-software compatibility matrix.
Well, I don't know what that. I can't picture in my mind's eye what that is. But you have let me put it this way. You're going to have an interface between elements. You can have an interface between test elements. For example, if I have a testing setup and I may need to make an interface with the type of equipment or subsystem that I'm working on, the use of the component class is not limited strictly to just systems elements. So I can make a folder under components, and I could call it, test configuration items, and within there, that would track the hardware and software that I'm using to actually test the system. You can't see a matrix per se. When you say a matrix, you're really looking at a table with one element on a series of elements on one side, a series of elements on the other side, and maybe a series of check marks in there. But you can show the interfaces and things between those test elements using an interface N2 diagram or things like that. And I might be able to expand on that more, but I really don't have a picture in my mind's eye of what this matrix would look like.
Okay, and just for everyone out there, anytime you want to further discuss something with us, particularly about these types of things with methodology, we recommend that the first route you take is to email our support team at support@vitechcorp.com, and then if it's something that Ron can help with, support team will get in touch with Ron, or if it's something that can be answered directly by the support team, then they will do so. Okay, I've got another question here. Let's see. It says, what is the main difference between this tool language and UML testing profile or SysML?
I'm not familiar with the UML testing profile. I'm very familiar with SysML, and we draw a number of SysML documents and support a number of SysML drawings in core. So we have the structure BDD, the classification BDD, interface drawings, link drawings, or physical drawings. And then in the functional side, we can do things like activity diagrams and sequence diagrams and IDEF0 diagrams and N2 diagrams. So we really do support the SysML language. But there's more to systems engineering than what's in SysML, and we support other drawings that are truly as valuable or more valuable in some cases than the SysML drawings. For instance, our rich library of hierarchy diagrams and our ability to draw spider and entity relationship diagrams as we go along in the system design. So.
Okay, thank you. And we've got a question from Alfonso. Can core generate the actual test protocol?
Test protocol, and by that I think you mean the sequence of tests?
He says here, I mean by protocol the series of steps to test a given subsystem or system, the actual inspection and test activities.
No, I wouldn't expect to do that in core. What I would do in core is when I have my test procedure here, like if I was doing this data entry test procedure, that test procedure really should be, it is generally, I shouldn't say really should be, but it is generally created by the testing evaluation engineers using the artifacts that are in the system design. So I could look at this data entry test procedure if I had a functional flow block diagram up here of the data entry, let's say it was this particular thread or whatever, then I could show this thread, and this thread would be used to, for example, go through all the steps that I would take in that test procedure. But that Word document test procedure is right now not a formal document that we produce automatically by a script, and the way we envision it being done is that test procedure would really be done outside of core, and I would augment this database access test procedure, if you will, with the actual external file that would be the database test procedure. And this database test procedure, this element in the database would actually link to wherever that artifact is in our data repository for the system design. So we would link to some place in our data repository to that actual Word document. Okay.
Okay. There is a question here from Stephen, and he's asking, could we have a course on the best ways to pull information from other models or documents into Core? I'm going to go ahead and answer that one. If you go to our website, so to vitechcorp.com, and click on My Support, there is a webinar that's there. You're going to need your serial number to be able to log in if you don't already have a My Support username and password, but we do have a webinar that we did for our customers that is methods of inputting and outputting data in Core. So we do have that, so I highly recommend you take a look at that. And then the next question I have for you, Ron, is the RVTM the only traceability report, or can others be generated?
You can generate whatever report you want in Core in that regard. These, in fact, the reports I have here, when you look at this list, only about 10 of the things that are on this list come in Core out of the box. The rest of these are all created. I can create my own report, my own table, my own CSV extract in Core using this export wizard. So I can start with requirements here, and I have requirement name and number and element, and if I want to look at requirements that are the basis of functions, then I can do that. And I can just list for all the requirements, what basis of function, and from that I can pull out the from that. So I have to, I can just, I'm just sort of constructing one here on the fly, but I can just make my own table to do whatever I want. I can customize this to whatever level I'd like to customize it. And you can save it under your customized name. But in Core 9, you can do this to trace whatever. And I obviously made a mistake here because I didn't pull this in right. But let me just start again here. But you can do your own traceability. As you want, as much as you want going through here. It's not the bait requirements are. So I'm just I haven't really thought about what I was trying to do here. So you can customize your own CSV table to do whatever traceability you want.
Okay, and this might be a similar question. I'm not the technical expert to be able to know, so I'll go ahead and ask. Can test cases and scripts be created and statused in Core?
Test cases, in other words, you want to create a test procedure, and that's what I'm going to call a test case, is really a test procedure. And what I think you mean the script, the development of a particular software script to do a test. We don't create a software script in Core. We don't auto-generate the software script in Core. So I don't know how you would. I don't know exactly what you're trying to achieve, but I could actually create in our test procedure. I could write. We could categorize all of the tests that you're actually writing under test procedures, and then you could status those.
All right. Yeah. There was a clarification, not the software, but steps. But specific steps of what to do, whether it is an automated or manual. Okay. and then I got a thanks. So I think we're good on that one. If not, please message us and we'll let you know. Let's see.
Yeah,
Okay,
if you wanted to further categorize test procedures, you can easily do that by extending the schema and add some additional categories. So if this test procedure was an automated software test procedure, maybe that's another attribute, or you want to put that into the description, or make a new attribute here on test procedures to show what, you know, the type of test procedure that it is. You can easily do that in Core.
Okay, we've got time for one more question. So I've got one here from Stephen, and he asks, when you develop the test configuration, you can form the system configuration under tests from various components. If I wanted to show a progression of verification events from preliminary design test to final design, how do you document the maturity of the system in the verification event? I know that was a long one.
You don't do it in the verification event. Let me explain. I'm going to go back up to test configurations. Can utilize components. So you may have in Core. Let's look at a test configuration. Okay, test configuration is formed by a component. So if I had test configuration items here, or let's say I had developmental items, I could, under my component class, make a new folder of developmental items, give those developmental items names, and characterize them like I can any other component, and say that I'm doing this test procedure with developmental items. And if you look at a component here, you could easily add another attribute to a component to show its maturity. We have on the secondary page the ability to add. We have a lot of other things we can add on the secondary page, but we can show here the maturity of the component that we were putting under test. So you could call it developmental items or whatever. Now, what you call a developmental item is very specific to your process and procedure. So.
All right, well, thank you so much. I know that there's some questions that are continuing to come in, and I will get those over to Ron so that he can reach out separately and we can try and get those answered. You guys did a great job with the questions today. Made sure that Ron worked hard to earn his paycheck today, so thank you so much. And if you have any other questions or comments for Ron, if you could pull up the screen with your email address again so that we have that. We would all be happy to hear from you with any inquiries you may have. You can also email support@vitechcorp.com for any additional questions. You can also post your questions and comments in the forum of our community site at community.vitechcorp.com or on Vitech Corporation's LinkedIn group page. And I'll chat out the link to the community page right now, so that's coming your way. And thank you so much to everybody who came today. We hope that you are ready to really get going with your test and evaluation in Core. Our next webinar is going to be focusing on states and modes with our special guest, Charles Wasson. The link to register is on our website, and I will also send that out through the chat window, so that is coming as well. And we do have one more note. At the conclusion of the webinar, a survey is going to open on your screen. Please take a moment to give us feedback on today's presentation or on what topics you'd like to see covered in future webinars. We do look at your feedback and use that to improve this experience for you. That's all we have for today. And once again, thank you so much and have a wonderful day.